ever walked outside on a hot day and thought, why does it feel so sticky? Or maybe you've noticed water droplets forming on a cold glass of juice? What do these everyday experiences have in common?
The answer is atmospheric humidity. Today, we'll discover what humidity is, how it forms, why it matters, and how it affects our weather and our everyday lives.
So by the end of this video, you'll be able to define atmospheric moisture and humidity, explain how humidity is measured, describe its role in weather, and recognize why it is important in our daily lives.
Let's begin with atmospheric moisture. Atmospheric moisture refers to all forms of water found in the atmosphere. This include water vapor, liquid water droplets in clouds, and ice crystal found in high-altitude clouds. The most important forms in water vapor, which is an invisible gas produced when water evaporates from ocean, lakes, rivers, and even plants through transpiration. Although water vapor makes up only about 0 to 4% of the atmosphere, it plays a major role in weather and climate.
Humidity is simply the amount of water vapor present in the air. Think of the atmosphere as a sponge. A dry sponge can absorb plenty of water. A sponge that's already wet can hold much more water. Air behaves in much the same way, and warm air can hold more water vapor than cold air. That's why humidity changes as the temperature changes.
The most common measurement we hear in weather forecast is relative humidity. Relative humidity tells us how full the air is with water vapor compared to the maximum amount it can hold at a particular temperature. For example, if the air can hold 20 grams of water vapor but currently contains only 10 grams, then the relative humidity is 50%. As temperature rises, air can hold more moisture. If the amount of water vapor stays the same, the relative humidity decreases.
So humidity constantly changes through two important processes, evaporation and condensation. During evaporation, heat from the sun changes liquid water into water vapor, adding moisture to the atmosphere. As the warm, moist air rises and cools, condensation occurs. Water vapor changes back into tiny liquid droplets, forming clouds, fog, and eventually precipitation. Together, these processes are part of Earth's continuous water cycle.
Have you ever noticed water droplets forming on the outside of a cold drink? That's because the surrounding air cools to its dew point. The dew point is the temperature at which the air becomes completely saturated, meaning it cannot hold any more water vapor. At this point, condensation begins.
Humidity affects many aspects of our daily lives. In weather forecasting, humidity helps meteorologists predict cloud formation, rainfall, and severe storms. In agriculture, farmers monitor humidity to protect crops from disease and manage irrigation. In aviation, humidity influences visibility, especially during fog, while indoors, maintaining the proper humidity helps prevent mold growth while improving comfort. So humidity also affects our bodies. When humidity is high, sweat evaporation more slowly, making us feel more hotter than the actual air temperature.
Let's review what we've learned. Atmospheric moisture includes water vapor, liquid water, and ice crystals. Humidity measures the amount of water vapor in the air. Warm air can hold more moisture than cold air. Evaporation adds moisture, while condensation forms clouds and precipitation. And finally, humidity plays an important role in weather forecasting, agriculture, aviation, climate, and even our personal comfort. And that concludes our discussion on atmospheric humidity and moisture. Today, we've learned that even though water vapor is invisible, it plays a vital role in shaping our weather, influencing our climate, and affecting our daily lives.
By understanding how humidity works, we can better understand the atmosphere and the science behind the weather we experience every day.
Thank you for watching. I hope this presentation helped you gain a clearer understanding of atmospheric humidity and moisture. Stay curious, keep exploring the wonder of science, and see you in the next lessons. Bye!